Murtha. I am with AECOM. I run all of our advanced mobility practice globally. So I lead our work with automation. I lead our work with advanced air mobility and also with payment systems and connected vehicles and automate. Everything fun in transportation is what I get to lead. So we're going to focus today on advanced air mobility. I'll also talk about some terms before we get going. So advanced air mobility is an umbrella term that we use to describe drones and eVTOLs. eVTOLs are the vehicle, drones are the vehicle, advanced air mobility is the concept. Sometimes other people use the term urban air mobility, also a subset of advanced air mobility. Okay, so those are the terms. Another term is automation. So you won't hear me say autonomous, which is a commonly used term. The standardized term with the Society of Automotive Engineers is automated. So we talk about highly automated vehicles or fully automated vehicles, but in the technical world, we don't usually use the term autonomous. Okay. All right, so you may have heard of AECOM. We're huge. We're the biggest engineering consulting firm in the world. We have a lot of people. And I'm in our global group, so I get to work all over the world to coordinate all the work we do on advanced mobility everywhere. One of those things that we do all over the world is advanced air mobility. As I mentioned, we're super excited about this new technology. It's going to involve designing corridors. It's going to involve coordinating applications of the different vehicles. It's going to have a lot of great aspects. There are significant advantages to using an eVTOL over traditional aircraft. It requires no runway, so it requires less space than historical vehicles. It's electric, which is great, and we'll also talk about the challenges related to that. It has zero carbon emissions, at least at the charging point. It can have multiple different types of power. It's quieter, so there are a lot of concerns about the sound related to eVTOLs, especially as we are used to helicopters in this case. So we know that from initial studies that eVTOLs will probably between 45 and 60 decibels, which is close to the sound of a vehicle in front of your house. It's also able to go point to point, and we're hoping that we can move the congestion off the highways with this. Probably that number is about 5%. And also it is impactful on both the passenger and the goods movement. And it's real. So we're seeing huge investments in it, and I will dig in a little bit more into the investments in the technology. And we are going to see launches this year, and I'll talk a little bit more about those too. So in the next 5 years, we'll see the initial launches, right? We'll see the trials, we'll see Paris Olympics, which I'll talk about. 10 years, we'll start to see routes actually starting to develop and people and goods starting to move. And within 15 years, we expect we'll have largely networks built out and regular movement of people and things. There are over 700, close to 800 different types of aircraft being developed in this space. It's a big number. I expect that those will be filtered down, and probably the most commonly used will be the ones that are actually constructed the most. So the big manufacturers. So you may have heard of Joby, Archer, Volocopter. EHang is important in this market here in Hong Kong, in China. Beta is another big one. Eve is out of Brazil and the US. And if you want to take a minute, if you want to take a picture of this slide, you can see, hopefully this is somewhat updated, you can see some of the actual investment that's going in, that's going into this. You know, I'd also point out here, it's an important and interesting point that we see different types of investment. We see full cash investment. On the coming slides, you're going to see investment in terms of pre-orders of vehicles from several large companies in the world, and you also notice that there are SPAC investments, which are different types of investment, pooled funds investment over different types. So that tells me that unlike automated vehicles, which is another area that I support, we have a lot of investment in this technology. And broad investment too. We'll look at those slides in a little bit. The vehicles operate at different ranges and have different amounts of people that they can carry and different amounts of goods. They have different business models. Each manufacturer has a different approach to how they want to go. We're going to see a slide later where we see how far the vehicles can go across the city. So meaning that some of the vehicles, some of the manufacturers and operators want to go short distance and some of them want to go longer distances. So I mentioned investment in terms of pre-purchases. So this is pretty exciting. For me, coming in advanced mobility, I've actually never seen this much investment in a new technology until now. So we see investment from most of the major airlines. There are probably some Asian ones, which I left out. But we see big investments from American Airlines and partnerships from Virgin and United and Delta. Very interesting also to me is that something that I've learned over my career is that it's always easier to move goods than people, right? So when we think about a train, at least in the US, our companies that move freight have priority on the rail lines over the companies that move people because it's more profitable and easier to move goods than it is to move people. So I was surprised about 4 years ago when I really saw investment in advanced air mobility investment really focused on people and not focused on goods. That was very surprising to me, atypical for investments in technology for transportation. And now we see, in the last year and a half, we see a lot of pre-orders from freight and goods movement companies. That's very interesting, and I think that that's great because that's a really good way to get things started at a lower level of risk. So that's exciting. I wanted to share some of the early launches. So you saw the Chinese, or you saw the Hong Kong Bay Area launch, and I have a slide or two on that a little bit later. I suspect that we're going to see the first launch route, the first big deal. It will be the Paris Olympics. So look for that. I think they've been planning that since as long as I've been working in this area at AECOM, so that's like 3 or 4 years. And they meaning the Paris Air. There's an organization of the airports in Paris. And so they've been planning this for years. So look for 5 routes at the Paris Olympics, not permanent routes, but 5 routes to move people around at the Olympics. I think it's a volocopter. I think it's only going to have 1 or 2 passengers maybe. So it's not significant movements of people, but it's significant in terms of visibility in the world stage and advanced air mobility. Please look in the Middle East for what I think will be some of the first regular routes. So think some of the bigger projects in Saudi, which we're all under NDA about if we're working on them, so we can't talk about them, but we know that the Saudi developers are very, very interested in getting this off the ground first, and we have seen Dubai make announcements with many different manufacturers with regard to their interest in buying eVTOLs and launching them for routes. So that's what I suspect will be the first regular routes. In the US, I can talk publicly. We are supporting, AECOM is supporting the Port Authority, New York, New Jersey, and some of their plans to connect southern Manhattan to JFK Airport, so look for that. Also Florida and Texas, all of the warm spots that don't have ice, please look for those to be some of the early launch spots. It's easier to do advanced technology there because we have less interference in the sensors, in the LiDAR and radar, where there's no snow. So I know that we are planning, it's in the news, we're working with Ferrovial, which is a very large infrastructure owner-operator. They also own part of JFK Airport. And we're working with them in Florida to build out a series of vertiports across the state to move people there. So these are some ideas about where some early deployments might be. And I might be wrong. Okay, so in terms of applications, there are a lot of different applications we talked about here. We talked about air taxis, we talked about commercial goods movement, we talked about aerial tourism. For example, in Australia, in Sydney, there's a company that does that does tourist flights around Sydney Harbor, and they have already acquired, pre-ordered several eVTOLs as well. So we know that that's going to be an application. And then applications like firefighting, emergency medical services, and search and rescue. I can also tell you something super exciting about that is that one of our favorite clients is in North Carolina, which is a state in the US. It's the state where the very first aviation, where the flights happened, where the Wright brothers invented flight, happened in North Carolina. So I am their advisor for advanced air mobility, and North Carolina is actually planning to buy eVTOLs. The state is going to buy eVTOLs to develop its own transit system using advanced air mobility to execute some of the applications that are across the bottom. So that's super exciting. And then also the federal government in Australia has talked about the same thing. So now we have not only public sector or private sector investment, but now we have public sector investment in transit for using advanced air mobility. Very exciting. Okay, so I wasn't here for this flight, so there might even be people here who know more about this than I do. But we did see the first intercity trial flight here, near here, and it worked. So as a result, we're very excited. AECOM has been working with some of the Hong Kong government for a while and talking about advanced air mobility. And so we're hoping that this sort of spurs some more planning along. I think we'll want to start planning where the vehicles will land. That's the hardest thing, by the way. That's the hardest thing in what we do is actually finding a location for the vertiport. And I can talk through some of those challenges, but I think we're going to face them here in Hong Kong pretty soon. All right, so when we're looking at where to put the vertiport, we're looking at the impact on existing traffic, so integration with the other modes. In early advanced air mobility deployment, it's going to be super important to be able to move large amounts of people to where large amounts of people are. Again, think Lower Manhattan to JFK Airport. This is because we have to create a large return on investment for all the folks, for all the companies that have made investments in this development of this market, really need a quick return. So we're going to have to be really careful and judicious about making sure we can move enough people and we can pay for this deployment. We have to look at where we can have enough electricity to charge them. They take a lot of energy to charge. There aren't a lot of places that have access to that much grid. We also want to make sure that if we need to, that it's going to be expandable in the future, and also consider noise and airspace. So this is a nice slide that sort of explains the altitude of where the vehicles would operate. Think it's right at about helicopter length, and it's going to become more integrated as we move on through time because there are going to be more vehicles in the air. So also thinking about traffic management. So there's not a good solution. There's Eve, one of the manufacturers, is also looking at a traffic management solution, but none of that is solved yet. So that's something to look forward to being solved. Okay, so my team put together some great travel time comparisons. I really like these. So we can sort of understand that the vehicle can really cut down on time. So in the beginning, they will be expensive. So I'm estimating, and I'm going to be wrong. Okay, but my estimate is maybe like the same as a helicopter flight. Maybe $500 US to go 10 kilometers. Approximately, right? So that's in the beginning because we need to pay off the investments in these technologies. And for many people, this kind of time saving that'll be worth it, right? So, but ultimately, the manufacturers and the operators are really looking to have the price drop down to around the price of the most expensive Uber. In the US, I think we call that Uber Black. I'm not sure what it is everywhere else. It has a different name everywhere. But I think the highest, most expensive type of Uber is what the price will be equivalent to. So meaning that more folks can access this. Okay, a couple more really good travel times, which I think are very helpful. So comparison here to drive times. Very helpful. I mean, I think that a lot of people will be interested in paying that much. Okay. This is one of my favorite slides. So remember I mentioned that a lot of the manufacturers and operators have different models in terms of what lengths they want to go and what problems they want to solve. This is a really nice slide because it explains who can go where. And we did this slide in the U.S. first along the eastern corridor because we really see that we can cover almost all of the most heavily traveled routes in the country with this kind of distance. It can make massive improvements in travel times and within a whole region. All right, so deployment at airports. So folks are often thinking about how we would fit into airports with eVTOLs. Are we taking them? Where are we going to have the vertiports? So airports is one of the ideas. Airports are actually super challenging, and because if you know anything about aviation, basically the big airplanes already have all the good airspace. So this top diagram, you see the takeoff and landing areas of an airport are really done with wind analysis with the primary wind, the best wind space to support takeoff and landing. So one of the problems is now the eVTOLs are, unless they want to compete with the giant planes, are really stuck in the bad airspace. So we're working with a lot of our airport clients to try to figure out the best spot near airports, and wind analysis is part of that. So in the bottom left-hand corner there, you can see also going to be a major problem as we deploy in cities. I know that many cities are very excited about having this on rooftops. That's a major challenge. That's a major challenge with the wind analysis. It's a major challenge with moving a lot of people off rooftops, and also a lot of challenge with getting charging. Okay, so despite all those challenges, here we have these are major U.S. agencies that are already undertaking planning to do this. So I mentioned we're supporting North Carolina, we're also supporting Texas, and North Central Texas Council of Governments. This is just a sample. So I have the slide here to tell you that everyone else many other agencies have started planning. So if your agency hasn't started planning yet, or the people you support haven't started a planning document, now's a really good time to do that. I wanted to fly through, I only have 3 minutes left here, so I'm going to fly through some of our vertiport designs. At AECOM, I'm not trying to do a commercial, I'm so excited about this. Okay, so we are supporting the deployment of advanced air mobility through 3 of our areas of expertise. So me, on the surface transportation and automation type areas, our architecture group is supporting and they are designing vertiports for Ferrovial and others. And also our aviation team is supporting with a lot of expertise on all the rules related to aviation. So we're super excited about that. I am super excited about that because I think it's really cool. And so these are some of our designs for vertiports, and I'm going to share some of those with you. We have had to make them configurable. We have had to make them scalable and easy because I mentioned that there's not going to be a lot of money. This is not going to be a highly profitable industry. So any vertiport designs you see that have bars and malls in them, not going to happen. Okay, some of our concerns that that I mentioned, we're looking at expansion, power needs, huge consumption of electricity. So we have to be concerned about that. Battery fires. If you are tracking any of the science or experience related to battery fires, to put out a car battery fire, it takes 2 full fire trucks or 6 hours to burn out a battery of a car. So you know that it's not going to be easier for an eVTOL. So we really have to have space that have fire suppression. Security, same as an airport, how do we work that out? All the vertiports have to be compatible with different types of eVTOLs. I mentioned there are 770. We'll probably have to be compatible with 10 or 15. And also make sure we're addressing ESG concerns. I already mentioned a little bit about the business model. We're looking at needing to scale. I mentioned that the financials will be tight. We will have to have high frequency, high throughput of people in and out of the experience. And we are going to want to be able to have buildings that we can build out as more passengers come by. So that's what we're looking at. There are several vertiport operators. Our favorite is Ferrovial. Then there are also folks, Skyports and UrbanPort are also looking at vertiport design. But when I'm looking at these, the one in London, there's an air taxi vertiport in London, and that is one of the ones with a bar. And we're seeing that probably is not a good business model. All right, I wrapped it up with 56 seconds to go there, and I invite you to give me a shout and ask any questions that you have. I can also answer questions about automated vehicles. We're deploying automated buses all over the U.S. that tenders on the street, so all kinds of fun stuff to talk about, and I'm happy to take your calls or questions.
Thank you, Ms. Murtha, for such informational and visionary insights. We can't wait to see eVTOL in Victoria Harbor.
Yes,
Right.
that's right, yeah.
Please be seated. Thank you
Okay,
very much.
you're welcome.
Thank you.